episode, we are looking at chain rule for multiple variables. But before I go on to chain rule for multiple variables, I would like to refresh our memory. Okay, take us back to calculus 1. Okay, you have this. You have g of x inside a function f. Okay, so if you have this, according to chain rule, the differential, okay, will be equal to what? You differentiate the outer function, okay, and then while you keep the inner function, you keep it constant. And finally, times the derivative of the composite function, derivative of the inner function, and that will be g prime of what? Of x. So that's that on chain rule. Let's go further also. If y is a function of x, and this s is also a function of t, we can get the y, the x. You differentiate this one is a function of one variable, that will be the y, the x, and then times this one. Also differentiate this one. This one is the x, the t. This one is a function of t. So you differentiate this one respect to t. So times what? Times the x, the t. Okay, but we want to go to several cases chain rule where we have more than one variable. Look at the first case of what we have here for chain rule. You can see the z is a functions of x and y, and each of those functions, x is a function of t and y is a function of t. So since each of those variables are functions of t, then this one z will now become the z, the t. So in this place now, you are going to get your what? You're going to get the x, the t. Here you're going to get the y, the t. Now come back here. So this will become what now? This is a function of two variables, and that will be equal to what? Del f, del x times the x, the t, then plus, again, eventually this one, partially respect to y. That will be del f, del y times the y, the t. So that's how to compute the z, the t. Those ones are functions of two variables. You differentiate each of them partially respect to the given functions, and then this one, those ones are functions of one variable. You do the differential. I mean the x, the t, the y, the t. So that starts on this. Okay. Without further ado, let's go straight to questions. Compute the z, the t for each of the following. Z is a product of x e to power xy. X is a t squared. Y is t minus 1. Let's see solution to that. If you check the question, the z is a functions of two variables. So we're going to get a partial derivative respect to x. This one is the same thing as well. Del z, del x. You differentiate this one. That's 1. You keep this one constant. Then plus. Keep your x constant now and differentiate your e function. Look at the power. If you differentiate this power respect to x partially, it's going to give you 1. So this y is a constant. So we have what? We have this. Z, y. Your x constant, you differentiate your e function. Derivative of this one, xy, respect to y. In this case, you keep your x constant, you differentiate your what? Your y, which is 1. So we have what? Times x, which is what? Squared. Now this one is a function of one variable, so we get the x, the t, which is 2t. This one will be equal to, that's the y, the t. This will be equal to, the minus will go to the front. So that's minus 2, that's minus 1 over what? T2. So that's all the parameters you need. Let's try to make the function to be of the same variable. But we're having t here, we're having t here. All this one, they are functions of x and y. So we can make substitution. Your xy is equal to this one times this one. That's a t2 times a t1. That'll be t. Xy is t. What again we need? Out of x squared will be equal to t to the power 2. That's a t squared to the power 2. That's t4. This one, these are del z, del x. It's going to give us what? E to the power t plus t et. Xy is t. Xy is t. And this one will become what? This one will be x squared. That's t4 times e to the power t. So let's do the substitution. Get the formula. The formula will be the z, the t, and that will be equal to. So don't forget the x, the t, that's 2t into brackets, the z, del x, then plus this one, the y, the t, this one, that's a minus 1 over t squared. So this plus we cancel into brackets. The z, the y, check that. Okay, so this is your the z, the y. Let's open these brackets. This one we cancel. This one also remain at t2. Answer is 2t e to the power t. This one and this one. This is plus 2t squared e to the power t minus t squared e to the power t. So it remain 1. So plus t squared e to the power t. So that's the d dt. At this point, there's a watermarks on the video. Kindly smash the watermarks and subscribe. So that anytime I upload, you get notified. Don't stop there. Click on like button and begin to what? Type your comments. Finally, share the links of this video massively on all your social media platforms. Let's go to question 2, the B part of this question. Let's go to the B part of this question. The B part of this question, we have z is equal to x squared y cubed plus y cos x. Okay, and s is equal to natural logarithm of t squared, y is equal to sine 40. So the z is a function of two variables. To do, let's get the del z del x, which is the same thing as what? As this. So you keep this one constant, you differentiate this one, and that will be 2xy to the power 3. This one, you keep the y constant, you differentiate this one, and that will be what? Minus sine x, which is right there. Let's get the del z del y, which is your x squared constant. Differentiate this one. That will be 3y squared x. Come back here, plus. Differentiate your y, so you keep this one constant. That's cos x. So let's get this one. X is a function of t. So that will be dx dt. So differentiate t squared, that's 2t over the function itself. And that will give you 2 over t. Let's get the y dt. The derivative of sine is cos 40. So times the function inside. Times the derivative of the function inside. That's 4. We have our formula. Then we can begin to make substitution. This one, dx dt, that's 2 over t times this one, then plus the y dt is 4 cos 40 times del z del y. So this one. Let's begin to substitute so that to try to have the function in form of one variable. Well, it's not compulsory. It's not a must. Let's do the substitutions. So 2 times 2, that's 4. So we have 4, and then y cube. Y is this line t squared. Don't forget the t. The t is going to come in. Everything is going to be all over t. Okay. Then here also 2 times y. Okay. So that will be 2 times y, that's plus minus 2. My y is what? Sine 40. Sine, my x is what? Put your x there. Okay, so that's what we have for this first part. Okay, let's do the same thing for the second one. Plus 4 cos 40. Open your brackets. That's 3 here. Y square is this. S square, if you do this one, okay, then plus cos x. So that's that on these aspects. Okay, we just make the variable to be of the same form, but it's not compulsory. It's not compulsory, but that will fetch you more mark. Okay, so that's that on these one of the chain rule. We still have other cases. So please check out the next video will be case 2. So check it out. Case 2 with question.